Okay, this is how to use, this is a short video on how to use the chain rule and the quotient rule with partial derivatives. So we'll go to share screen here and get up to the ladybug. And just take a second. All right, now let's consider the following question. Suppose we have f of xy equals, let's say, xy squared over x to the fourth plus y to the fourth. And let's suppose we'd like to calculate the first two partial derivatives, like so. Well, the thing to do is remember that when you're calculating the derivative, you have to use the quotient rule here, or that is a good way of doing it, because that has an x in it and that has an x in it. Now, if you remember the quotient rule from calculus, it said that if you're taking the derivative of the quotient of two functions of a single variable, you had the derivative of the first times the second minus the first times the derivative of the second divided by the second squared. And of course, this assumes that the denominator function is non-zero. Well, in terms of partial derivatives, how it works is that the said derivatives occur with respect to the given variable. So now let's just go ahead and take a look at the partial with respect to x. Well, taking the partial with respect to x, you square the denominator just like you did before. Then the derivative of the top with respect to x times the denominator, minus the top times the derivative of the denominator, and I just realized I did not give myself enough room, so I will remedy that now. I have to give myself room in this discipline. So the derivative of the top with respect to x times the bottom minus the top times the derivative of the denominator with respect to x. And so this becomes, still have this squared. Now you're differentiating this with respect to x. X sees the y as a constant, so this is the derivative of x times a constant, so you just get that constant. Minus xy squared. The derivative of this with respect to x is a constant, so it's 4x cubed plus 0. And I'll just go ahead and move this over a little bit. In fact, I'll take the picture here. And then if you simplify this a little bit, I'm not going to simplify it a whole lot. It's just a demonstration video. What we get was x to the fourth y squared plus y to the sixth minus 4x to the fourth y squared. So I guess there is a little bit of simplification you can do. And let's see here. So this works out to be y to the sixth minus 3x to the fourth y squared divided by this. Now the second, if we want to do this again, remember the function is x squared, xy squared. And you wish to partially differentiate this with respect to y, it's the same principle. You square the bottom. You differentiate the top with respect to y. So this is going to be 2xy times the bottom. Subtract xy squared. And then you differentiate this with respect to y. So that's another 4y cubed. And this works out to be 2x to the fifth y plus 2xy fifth minus 4xy fifth. And there's a simplification to be done here. But I'll just leave it at that and let you simplify this further. But remember the general principle. You have to use the quotient rule, but every time there's a prime here, you differentiate it with respect to the variable of interest. So that does that one. So I'll take a picture of that. Now, let's go ahead and do a chain rule one. And let's see here. Let's say you have f of xy equals natural log of x to the fourth plus y to the fourth. And let's say we wish to calculate the partial with respect to x. Well, in calculus 1, you learn that the derivative of log of u is 1 over u times u prime, right? Well, in this case, what you're differentiating is with respect to x. So here, if you're going to take the partial with respect to x, it's still 1 over u times u partial x. So in this case, it's still 1 over u times the derivative of this with respect to x. But that's a 4x cubed, and that's a 0. So we get 4x cubed x to the fourth plus y to the fourth. The partial derivative with y is dealt with in much the same way. In fact, you can get the partial with respect to y by just replacing the x's and y's by symmetry. But that tells you how to do that. So thanks for watching.